Our next session will be about mobile in containers work, presented by John Frizelle.
Thank you. Okay, good morning everyone. My name is John Frizelle. I am the Chief Architect with Red Hat Mobile. I come from Waterford, Ireland, so where the Guinness and the leprechauns come from. And I want to talk to you today about mobile in a containers world. So what does that mean? Most people would be familiar with what containers are: Docker, Kubernetes, OpenShift, etc. But how does mobile fit into this world? Containers are predominantly server-side, cloud-hosted, where mobile is on device. It's this. So how do we reconcile this with OpenShift, Docker, and Kubernetes? Well, they come together as part of what we call modern app dev. And we're going to talk a good bit about what modern app dev or modern application development is and how mobile relates to it. So, our agenda is the why, the who, the what, and the how. Why are we talking about this? Because of modern app dev. Who is involved in it? Who are the personas, the people involved in a modern app dev project, and what needs do they have from modern application development? What are the building blocks do we use to do modern app development? And finally, how do we actually do it? What's the physical tech stack we use for delivering this? So let's start with why. So over the last 5 or 6 years, we've seen this big change from what we call systems of record, these large siloed data stores in enterprises behind network, behind the firewall, not really accessible in the wild on mobile devices. Software is developed and delivered typically using a waterfall approach, typically meaning between 6 and 24-month delivery cycles. We've seen a big move from these systems of record to what we call systems of engagement. Mobile devices, phones, tablets, and God help us, even still some Blackberries. Isn't that right, Adam? And what we see with these systems of engagement is integrated data. So we're pulling data from multiple silos in this backend. It's out there in the wild on devices. And it's developed and delivered in a much more rapid fashion, typically using agile development methodologies. So this move from systems of record to systems of engagement is what we call digital transformation. And a lot of people will probably have heard that term. It's quite a buzzy term. And really what it means is that move from these silo data stores out onto mobile devices. And with digital transformation, what you're looking for typically is increased efficiency, so getting things done more quickly, reduced cost, much quicker turnaround, and typically what we call cloud-native hosting. So by cloud-native, what I mean is you're not provisioning physical servers into data center. You're possibly not even provisioning VMs. You're making requests to cloud services, the likes of Google, Amazon, Microsoft, for virtual machines, or to OpenShift for platforms, for containers, and for images. And what we found is that mobile is a real catalyst for this digital transformation. People want the data accessible on their device on demand. Customers, employees, and business partners all want to be able to interact with your systems without having to log on to a VPN or go into a physical office. They want to be able to do it from these devices. So mobile is really driving this trend for digital transformation. Digital transformation, in turn, has become a catalyst for what we call modern app dev. So if digital transformation is what we want, modern app dev is how we get it. And we're going to look at modern app dev in quite a bit of detail to figure out exactly what it means and who the key players are. Okay, so modern app dev, personas and needs. Who are the people involved in these projects? So we start with the business sponsor, the guy with the bag of money who wants something. Typically, this business sponsor will be responsible for initiatives, for portfolios of applications. And the kinds of needs this person has are high-level reports and dashboards that give an overview of the state of the current modern app dev projects, the ones in development and the ones that are already out there in the wild. So they want to know how the development phase is progressing, when apps are released, and what the uptake is, how many people are using them, how quickly people are upgrading, that kind of thing. You then have the poor project manager, the person responsible for actually delivering on a modern app dev project. The person who manages the project plan, brings it all together, and herds the cats. This person is responsible for delivery timelines. They're concerned with the quality of delivery, and they need metrics and analytics on how the projects are progressing. Are they tracking to the schedule that they're meant to be tracking to? And will these modern apps be available and in the hands of the end users when they're needed? Next, we have the security and compliance department. They're the people who say no to everything. Can we do this? No, that's not secure. So these are the people that make you stop and think about all of the risks. Who's going to access your data? How are they going to access it? How do you identify who they are and restrict access to only what they should be allowed to get at? These people are concerned about things like encryption of data, at rest in the backend systems, flowing through the network, and even on the mobile devices, because these are very easy to steal. And if you have corporate and sensitive information on the mobile device, if the physical device is taken, it's relatively easy for a hacker to get into it. So you need to be concerned about encrypting the data at rest on the device as well. These people are typically also concerned with things like auditing. So having a record, a log of who has been accessing what. Access control, as I said, to restrict access to only the people who should have it. And data management, making sure that backups are done, that they're encrypted, that possibly that they're stored off-site so that if there's a significant failure within your corporate network, that your data is still safe. We then have front-end developers, the people who build the user interfaces that the end users interact with to access your systems and your software. These people are concerned with things like user interface and user experience. How does the application look and feel? Are people able to understand it? Is it intuitive? Is it working as designed? And are people navigating through it properly? They want metrics and analytics on that kind of information. These are the people that need to be concerned with encrypting your data on the front end. So the security and compliance people will be talking to the front end developer saying, make sure that if you're bringing data down, that it's secure in transit and that it's secure in the front end. They need to concern themselves with things like debugging the front end of the application and making sure that the overall experience is as good as possible. We then have our backend developers. So these are the people that are typically writing the APIs that will be interacted with. These are the pieces that are hosted on a server or in the cloud somewhere. So they are concerned with things like data storage, making sure that as data comes in, it's persisted in the right way. Integrating into other systems. So these people concern themselves with things like message queues and business process systems. They typically have to be a lot more concerned with performance than the likes of front-end developers because they need to make sure that the systems will scale and grow as usage increases. And this is particularly important when you think about mobile apps because a popular mobile app can notch up 100,000, 1 million, or even 10 million downloads very quickly. So your back-end developers need to be thinking about the rollout of the applications and how these back-end systems will scale as the usage increases. They need good monitoring. They need to be able to understand what's happening in the back-end systems. They need logging to dig in when things go wrong. And typically these people will also want very solid CI/CD, continuous integration, continuous deployment systems, build and test systems that allow them to make sure that updates and enhancements to their code are tested and verified before they go out to production. Then we have our mobile developer. Much like the front-end developer, one of their primary concerns is how the application looks and feels and how it's used. But they also have other considerations and concerns. So while a UI developer will often be developing a system that will only be accessible on the corporate network, by its very nature, the mobile developer is building something that will run out there in the wild. So one of the things that they have to think about first is identity. Making sure that only the right people are able to access the app on the device. They need to think about things like two-factor or three-factor authentication, single sign-on, integration with device biometrics and things like that. They have to think about getting notifications out to the user. Push notifications are very, very popular, and they're a great way to interact with your users and let them know when something's changed. Another unique consideration of mobile is the concept of offline first. And by that what we mean is that quite often you're not going to have connectivity. You may not have Wi-Fi, you might be in an area of poor or low signal. And you need your applications to work seamlessly when your users are offline. And that's quite a different paradigm to typical front-end developers. These people are also thinking about what SDKs are they including in their application to build out their functionality, what device-level features are they making use of, what versions of operating systems of mobile devices are they going to support and test against, and are they building native or hybrid applications? Are they building only for iOS? Are they building for multiple different operating systems? And again, these people have a need around CI/CD. And for mobile apps, that can actually be quite difficult, because for building iOS apps, you have to have physical Mac hardware. So setting up a CI/CD system for mobile development is quite a bit more challenging than setting up a CI/CD system for a backend Java application or even a front-end website. And then we have citizen developers. So these are people, they're not really developers. They don't have formal training in software development. They're building mobile applications using interfaces, using drag and drop interface builders, process mapping systems, again, very much drag and drop and wire up the various pieces. So these are typically short-lived applications, relatively simplistic because they are constrained by the drag and drop form designer interface that people use. But you can get a lot of very valuable applications to market using citizen developers if they have the right tooling. And typically what we see citizen developers doing is replacing paper-based systems. It's one of the most important things that citizen developers get involved in. So rather than someone going with their clipboard and their raft of forms, a properly enabled citizen developer can give them a mobile app in typically 3 to 5 days that replaces what that form did and integrates with back-end systems so you don't have back-office staff having to re-key data from paper forms. Next we have our sysadmin. The poor sysadmin, often overlooked. The guy in the server room or the darkened room that everyone points the finger at when things go wrong. So the sysadmin is thinking about things like installation, patches, CVEs, vulnerabilities, upgrading and making sure that things upgrade properly or can be rolled back. Really, really, really interested in monitoring and metrics. A typical sysadmin could be managing dozens or hundreds of VMs. And when you start thinking about containers, thousands or tens of thousands of containers. And they need to know how all of them are performing in a split second. They need real-time monitoring and metrics. They have to concern themselves with things like configuration. So setting up development systems, separate from test systems, with configuration that makes sure that you don't end up with an app in development connecting to a live backend system. And I've seen it happen. I've seen customers of ours make that mistake. They do the configuration wrong, someone copies and pastes some environment variables from one place to another, and all of a sudden, you have, actually no, it was worse than that. It was the live front-end application talking to a test back-end system. And this was a customer-facing application. I'm not going to name the company, but suffice it to say it wasn't good. So your sysadmin needs to be concerned about things like that and making sure that the developers can't harm themselves and the organization by doing crazy things like that. They need to worry about backups, making sure that the backups run correctly and on time. And that, in and of itself, is quite a complex job. Making sure that all of the databases are backed up, encrypted, and typically moved off-site for storage. Then you have your support staff, the first line of defense for end users. These are the people that get the irate phone calls. It doesn't work. It hasn't been working for weeks. I click this button and nothing happens. What is wrong with you people? I'm sure several people in this room have been support agents. Out of curiosity, how many people have ever manned some form of a help desk here? Okay, for the rest of you, you're very, very lucky people. It's not a nice job. So these support agents need to be enabled to actually help people. They need to be able to dig in and get information out of the system at the level that makes sense to them. So they need some form of logging to see what's happening, but they don't want detailed developer debug logs with crazy strings and statements and JSON definitions and YAML files. They need logging at a level that allows them to help the user with their problem. Very often, the support agent will want to remotely attach to the system to help debug the problem. And that's relatively easy with desktop and laptop computers. There's technology out there, there's VNC, virtual identity systems that allow you to remote on. With a mobile device, that doesn't really exist yet. Or if it does, it's quite niche and quite expensive. They need to be able to pull dumps of systems to give to the engineers to analyze what the problem is. And again, they need metrics, so they have that high-level view. If they start getting calls about a particular app from a bunch of users, they need to be able to go to some kind of a dashboard and see, yes, something is wrong here. That's why I'm getting so many calls. So they need that real-time information as well. And then finally, the end user, without whom none of the rest of it really matters. Because if you don't have someone actually using your stuff, then what's the point in building it? So the end users are concerned with things like, I don't want to log in to every corporate app separately. They want things like single sign-on. They want the apps updated automatically for them and to be notified when a new version is available. They're concerned about their device. Very often in enterprises now we see the BYOD, or bring your own device approach used. So rather than enterprises spending tens or hundreds of thousands of pounds or dollars or euro or yen or whatever they spend on mobile devices, they allow people to bring their own devices and they install the corporate apps on them. So the user is concerned about that device. They don't want it subsumed into the enterprise. They typically don't want device management software on it. So we have this mismatch or imbalance where the user wants to keep their device as theirs, but the enterprise has to be concerned about the security of the device to make sure that they're not putting apps with sensitive data on them that can be compromised. So looking at all of these different personas, what we see is that mobile, it's not a siloed thing. It's not out here on its own the way it was portrayed back in kind of 2011 or 2012 when there were all of these mobile first initiatives. Because at that stage, people didn't really understand mobile well enough to be able to say what it was or where it fitted. We've come to a place now where mobile is just another channel for getting information to your end users. And it's part of the much bigger modern application development space. It's warm here. Okay, so let us now look at the what. What pieces do we need to assemble to do modern app dev? So one of the first things we need to consider is storage. A system is really only as good as the data that flows in and out of it. So storage is fundamental. You have to make sure that your storage is resilient and persistent and backed up. And you need to think about all of the different types of storage. So you have relational and non-relational databases, you have object storage, you have file system storage, and typically you then have caching, transient storage, close to the edge of network to ensure that the response times are as fast as possible. After storage, you then need some kind of back-end systems that will interact with that storage. Something that exposes APIs that can be programmed against, that allow the data to flow in and out of the system. So here you're thinking about what languages and technology stacks am I going to use? What languages are on the up? What languages are on the down? And what skill sets do we have in-house to build these back-end systems? Are we going to be cross-training people? Or are we going to be using existing skill sets? And are those technologies a good fit for this container world? Certain languages work a lot better in containers than others. So you need to think about that. You need to think about what languages will work best in your containerized environment. And then we're seeing a rise in popularity of what people call serverless. Now, personally, I hate the term serverless. I think it's a stupid word, but nonetheless, it fills a very interesting space. So it's like it's the platform for citizen developers for the back end. You don't really need to concern yourself with your full software project and your configuration files. You just write functions, you push them somewhere, and magic happens and they run. So serverless is really becoming a key part of this modern app dev paradigm, and it's something that we're going to see more and more of. Hopefully under a different name, but that's a different discussion. So we have our storage, we have our back-end development with our APIs exposed. We then need to start thinking about integrations. So different back-end systems talking to each other, talking to legacy systems, and talking to other parts of the corporate network. You have things like API mapping, so being able to visualize and define the mapping between the API of this system and this system, so that without having to write hundreds and hundreds of lines of code, you can map between two APIs and start to get data flowing through the system. In the space of integrations, you're also thinking about things like message buses and message queues. So rather than point-to-point HTTP communication between systems, you start thinking about more distributed message passing approaches for eventual consistency across your system. Next building block is security. So you have data, you have APIs, and you have them integrated. They all need to be secure, right from the edge of network, the whole way through. Security in your code, security in your integrations, security in your storage. You want to protect your APIs. You want to make sure that only people who are authorized to call the APIs are actually able to do it. So you stop people at the edge of the network from getting into your system. The way you do that is through user identity management. So you have to know who's making the requests. With each request that comes in, there needs to be some form of identity, some header, cookie that tells you who the person is, so you can ensure they're authorized to access what they want. And then thinking more specifically about mobile, you have device security. Is the device secure enough to run enterprise apps on? Has the user rooted it? Are there hooking mechanisms in place? Is there passcodes? Is the device storage encrypted? All of these things need to be thought about. Then we have analytics. So you've built and secured all your systems. You now need insight into how they're running. So with mobile devices, you're thinking about things like your install base. How many installs do I have across what device types, what versions of the operating systems? How often are the applications being started up? How many daily, monthly, or yearly active users do I have? And how are they using the system? So what are the user journeys that people are taking through the application? Which buttons are they clicking on? And where do they seem to be making mistakes? So forgetting to fill in a particular field before clicking the next button. So all of this information can be captured and crunched and processed with an analytics system. It also allows you to do things like A/B testing, presenting different user interfaces or different user flows to a subset of your users to see whether an update you're planning to make actually makes your application better or worse. So the companion to analytics is monitoring. If analytics tells you how your system is being used and what your end users are doing, monitoring tells you how the building blocks that you've used to provide the system are performing. Which systems are under load and need additional capacity provided to them? Which systems have lost connectivity between each other? Are there network faults in the system? You need a myriad of information from 1,000 different places to come together in the right way to give you the visuals you need to be able to see whether your portfolio of applications is performing in the way you expect. You need health checks on pretty much every system and every connection. You need access to logs to do detailed analysis. You need metrics. You need data on performance and uptime of the systems to ensure that your end users are getting what they want. Then we need collateral, the bit most people don't like to do, writing the documentation. It's all well and good to say to someone, RTFM, read the bleep manual, but if no one's written the bleeping manual, then you're going to be in trouble. So as well as building the systems, you have to document them. You have to document the internals of your code. You have to document your APIs. You have to provide training material and videos for your end users so they understand how your applications work and how to use them. You need hands-on guides and tutorials and blogs to help people fully experience the system you've built to the best of their ability. And then, as this is a mobile talk, you need your mobile client, your mobile device. And as we said, mobile is a little bit different. There are unique concerns around mobile that don't exist with web applications or with Backend. As I've already mentioned, things like data synchronization, so that your application works when it's offline. Management of the applications and upgrading of the applications, and that's a big one. With a web application, the software is running on a web server. When you want to do an update, you push new software out to the web server, and bang, all your users have the new version. With mobile applications, it's a lot more difficult. You have a copy of the application, the binary, running on each device. And pushing out updates can be very challenging, particularly in this BYOD or bring your own device world, where the app or the device is not enrolled in any device management, so you're relying on the end user to upgrade, and many people don't. I'm sure if we all took out our phones and had a look at pending app updates, there'd be quite a few. So you need to consider, how do you force this to happen? If you can't control the device, you need to control the application. So the application needs to be almost self-aware. What version am I running, and what's the latest version? Am I still in compliance with the corporate policies that have been put in place around versions? You need to build logic into the applications so that perhaps they don't start up at all if their version is too far behind the latest version. As I already mentioned, you need to consider things like device security, encryption, key locks, passwords, and things like that to make sure that the device is secure enough to run your application. So once again, what we see is that mobile is part of something much, much bigger. Pretty much all of the building blocks, with the exception of the last one, are not mobile specific. But to build a mobile app, you need all of them. So building mobile is a part of building modern app dev. You typically don't start off, well actually no, you typically do start off with an idea for a mobile application. So your business sponsor that we talked about at the start comes along and goes, I had a brilliant idea for an app last night. We wanted to do this, 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 and this. Sure, that's only 5 screens. You'll have that done in a week, right? Well, actually, no. Because we have storage and backend and security and compliance and all of the other pieces that we've talked about. It's a lot more than what you see on the phone. Okay. So let's talk about how we actually do it now. So with what we're building in Red Hat and as part of the AeroGear community, we're building a suite of mobile services that you enable on demand that run primarily in containers on Docker, Kubernetes, and OpenShift. We'll look at the services we're building in a couple of minutes, but let's build up the stack. So we start with Docker. I'm sure, is anyone not heard of Docker? Good, good, good. Okay, so Docker gives us immutable images that can then be instantiated into containers that run on a virtual or physical machine. They give you a catalog of images that you can reuse, so Docker Hub as the catalog. They give you tools for managing network configuration and access to persistent volumes, because Docker images by their nature are ephemeral. The data within the image, when the image is restarted, resets to what it was. So you need access to external data volumes to persist data. On top of Docker, we then layer Kubernetes. So Docker tends to think at the level of a single machine. Kubernetes thinks at the level of a suite of machines. So Kubernetes gives you the overlay that allows you to connect multiple virtual machines or physical machines together. It gives you a software-defined network that makes it look like all of the containers across all of the machines are running on the same network. It gives you namespaces to put your containers in, to separate and isolate the containers from each other. It gives you quotas and limits to ensure that containers don't run away with all of the available capacity. Because it's very easy to write bad software. It's very easy to write memory leaks. And if you don't put quotas and limits in place, what you'll find is a rogue container will start taking out all of the other containers on the machine that it's co-located with. So Kubernetes gives you these quotas and limits to restrict how much CPU, memory, network, and storage a particular container is able to request. And it also gives you scaling. So Kubernetes works with the concept of a pod that wraps around one or more images, and it gives you the ability to scale up the pods. It gives you lots of configuration options around things like affinity. I want these 2 pods on the same VM, or anti-affinity. Because I'm scaling up this web server, I want to try and make sure that it deploys its containers across all of the available VMs. So if one of them goes down, my system is still working. Okay, on top of Kubernetes, we then layer OpenShift. And OpenShift gives you a suite of functionality to extend Kubernetes. So it gives you things like lifecycle management. It gives you CI/CD out of the box. Jenkins is baked right in, and with the click of a button, you have a Jenkins server running that can do your CI/CD. It gives DevOps people a bunch of additional tools for visualizing and managing the containers that are running. It adds a layer of identity management and access control. So Kubernetes doesn't really concern itself too much with identity. It has namespaces for segregation, but it doesn't really go into the space of who can access what namespaces. So OpenShift adds a layer of identity management using the OAuth or OpenID Connect protocols to identify users and allow you to restrict what they can do in a particular namespace. Do they have no access? Do they have view access, edit access, or full administrative access? And it then provides a suite of developer runtimes out of the box. So a set of images tried, tested, and hardened for your favorite programming language, assuming your favorite programming language is one that the OpenShift people agree with. So you typically have things like Java, Node.js, Go, Ruby, PHP. I'm sure there are others. They're the ones that come to mind right now. So on top of that, we then add the Open Service Broker API, and in particular, the Ansible Service Broker implementation of it. So this is what allows you to provide that suite of services to people to deploy and run. So you start with a service catalog, which is where you put your available services, conforming to the Open Service Broker API specification, which Adam and Pavel went into in the previous talk. So with Open Service Broker, you define provision, deprovision, bind, and unbind. They're the four key things with Open Service Broker. So how do I get something running? How do I hook things together? How do I unhook them and tear it down? The Service Broker creates instances of service classes that are then bound to applications running on your favorite cloud provider. And that's one of the really cool things and one of the key things about the Service Broker API is that it's vendor independent. A bunch of the biggest cloud and container companies have come together to define the Open Service Broker API so that it's interoperable across OpenShift, Kubernetes, Amazon, Google, Microsoft, IBM, and others. So once you build something that conforms to the Open Service Broker API, you have a good degree of confidence that it will run across any of those providers. So they are the building blocks that we are building on. What we are now building out, what we're offering, is a suite of mobile services that help you build mobile applications. So we want the mobile developer to be focused on the business value add, not on the building blocks that are needed to deliver it. So we're starting with 6 key services: security, data synchronization, push notifications, API gateway, build automation, and metrics. We're going to look at each of them relatively quickly because I am running out of time. Security and identity management, we've already talked about it quite a bit. So we're building on top of an open source project called Keycloak. It's a JBoss project and is available as a Red Hat product as well. It's the core of the security and identity management. And we're extending that onto mobile. We're building a set of SDKs that interact with this Keycloak server running on OpenShift. 5 minutes. Okay. And that's security and identity management. Moving on. Data synchronization. As I already said, offline first is really important. So we're building and extending a data synchronization server that we've been working on for the last number of years. It ensures that your applications work offline. It gives you 3-way synchronization, so that's between the mobile device, our sync server running in a container on OpenShift, and your backend database. So it synchronizes data seamlessly across them with the piece in the middle handling collisions. So if a user has been offline for a couple of days, they've made changes to some data, they come back online, our system will synchronize the data, detect if it's changed in the system of record, and flag it so that a human can go in and manually resolve using a 3-way diff view to resolve the data collision. Push notifications. I think we all know what push notifications are. The AeroGear UPS project has been running for several years now. Quite a popular project on GitHub. That is what we're using as the basis for our push notification option. It does push for iOS, Android, and web. Gives you real-time stats on your notifications, how many have been delivered, how many have been opened, allows you to do targeted messaging to cohorts of users, and helps with the certificate management necessary to integrate with Google and iOS. API Gateway, we're building on top of an offering called TreeScale, which is an edge-of-network API gateway. And again, we're building SDKs that allow your application to be aware of the API gateway and route requests through it when the gateway is in place. The gateway gives you things like traffic management, rate limiting, access control, and analytical data on how network requests are flowing through your system. Build automation. AeroGear Digger is the name of the community project, and it provides what I would call cloud-native build automation for iOS and Android, for native and hybrid. For Android, it's a Docker container doing the build, managed by Jenkins. For iOS, it necessarily has to be physical hardware, but using Ansible scripts and tooling, a Mac machine can be added as a slave to the Jenkins instance running on OpenShift and allows for full automation of builds for iOS apps. With metrics, we're building on top of Prometheus and Grafana, and we're building out a set of SDKs that make it really easy to gather information on device metrics, versions of operating systems, versions of other SDKs in use, and we will be extending that to allow developers to capture metrics on usage patterns. So there are the 6 that we're targeting first, but there's a very, very big future. Serverless, as I said, is coming down the tracks at us. There's no avoiding it. Things like remote debugging on device, we're looking at solutions for that. Hot code push, being able to get new versions of an application out, even when the device is not enrolled in device management. Device test automation, this one is actually pretty cool. We're looking at a peer-to-peer distributed system for device testing that allows you to connect spare phones up to laptops, register them with a cloud service, and it mediates between those that want to run tests and those that have phones available. We're looking at things like dynamic configuration, being able to change the configuration of an application after it's being deployed. So enable and disable features and configure how the application behaves even when it's out in the wild. Okay, that's it for me. I would love to see you all again on GitHub, in the AeroGear org, working with us, trying out this stuff, ideally contributing. We'd love to see you. Thank you very much. Okay, do we have any questions? Come on. Thank you.
It's too easy too. But what was the name of the application that does the three-way sync? I missed it.
Okay, so the question was, what was the name of the application that does the three-way sync? At the moment, okay, so I need to provide a little bit of history to answer that question. So back in October 2014, Red Hat acquired a company called Feed Henry, a small startup based in Waterford, Ireland. And a part of the technology that came in with Feed Henry was this sync server we had built out. So it doesn't have an official product name. It is part of the overall Red Hat mobile product. But it is available on GitHub. In the Feed Henry organization, the repo is FH Sync Server. However, we're right in the middle of a redesign to move everything over to AeroGear. So in the next couple of months, it will be available through the AeroGear organization with completely revamped documentation, tutorials, videos, all that collateral stuff I said we need. So if you keep an eye on AeroGear in GitHub or aerogear.org, it will be updated there very shortly with access to all of these modules. Any other questions? Come on, surely there's one more. No? Okay, we can leave it there. Thank you very much. Cool.
So if I get it well, the arrow gear should be replacement for Backend.
Yeah, we're merging two communities. Yeah. So we've had a couple of years where we've been kind of trying to figure out, there was a little bit of kind of tribalism going on. There was an existing mobile development team in Red Hat that was under the AeroGear community, and then when the Feed Henry company got acquired, the upstream for it became the Feed Henry name. So we've been operating two communities for a number of years, and we're now centralizing them under AeroGear going forward.
Oh, right, good to know. Okay, so the next speaker is Success. Great. Today, I don't think so. We are there. So please just join us. Here we are not able to use the faculty connection because it's useless, but we have our own.
It's working.
Yeah, that's perfect.
Because yesterday it was.
Yeah, it was terrible. I mean, you can
I see you recording the video for YouTube.
we are recording it, not streaming. Yeah. I'm not sure right now. You've got an hour session or 30 minutes?
An hour.
An hour. Okay. So you've got 43 minutes for the speech, 10 minutes for Q&A. We will show you the signs with the remaining time.
Okay. It's actually streaming the previous session online.
It was online?
Yeah.
Oh. So they fixed it. Okay.
Два экрана типа, хочешь на дублирование?
The window. Yeah.
Single display. Правее. Мира.
Это.
Да, воно. Сто. Можно его ближе сюда. Так, тут. Так і що? Так, це не так. Це отак.
Sorry. Can you? Yes. Just keep it open. Keep it open.
По сути, там только вот это поднесла.
Нет, ну он же
Не для да. Может попробуй посмотреть, как оно будет выглядеть. Ну, размеры DE, помнишь, что надо увеличивать его, потому что оно очень мелко. F11.